everyone, welcome to JG Chem Masterclass. Guys, in today's video, we are going to learn about 3 and 4 membered heterocyclic compounds by taking example of Aziridine and Azetidine. The video is very important for all the M.Sc students and the CSIR students. And you can see here previous year questions of B.Sc University which we are going to discuss. So first we will see here propose various reactions given by aziridine and azetidine. So here we will see reactions first for aziridine, and as it is a three-membered ring containing nitrogen atom, we will see the ring strain will be present, and so you can see ring opening reactions are the most favorable reaction for aziridine. So here first we will see, so this is a aziridine ring having a substituted aziridine ring. Here Q represent the aromatic ring phenyl. So you have a three-membered ring having nitrogen which is called aziridine. In the presence of acid, the protonation will occur on the nitrogen, and there are the possibility of the two products. One you can see is the minor one, 1% yield, and other is 99% yield. After ring opening, we will see it how we are forming it through the mechanism. So first is the lone pair which is present on the nitrogen will take the proton and will be protonated. So the nitrogen is now having a positive charge, and therefore the two adjacent bond will try to stabilize this charge by giving its electron. So the possibility is either bond will open. So if you think of this bond to open, then it is generating a primary carbocation, and if the pH bearing bond is open, so you will get here the benzylic carbocation. You can see here benzylic carbocation, and if you know the stability of carbocation, we know the benzylic carbocations are more stable, and so the product which is going to be formed will go through with this intermediate stage only, and therefore the Cl minus, which is the nucleophile, will attack on this site, and therefore you can observe here this structure will be in 99% yield you will get here. With the excess of HCl, you will be having here salt form of it, and this is how the ring opening will take place when the aziridine ring is substituted by phenyl at that position 2. The second reaction, again you can see here, we will see nitrogen is acting as a nucleophile here, and you have an electrophilic site, the electrophilic carbon is there, and the ring opening will take place in the same manner like we have seen just now, and you will get the product. The ring opening will be taking place by either side because it is symmetrical, so you can open it from either side. Similarly, you can see this question where you have the malonic ester. In the presence of base, the proton is abstracted, and now this is going to act as a nucleophile, and you have the two electrophilic carbon here. So since it is symmetrical, it will attack to either side, and the ring opening will take place to give you this intermediate. Since the sigma bond which is going to open the ring, the electron will come on the nitrogen, and you can see here the intramolecular cyclization reaction with the loss of OET here, and you will get the final product which is a 5-membered containing one nitrogen atom as a heterocyclic ring. So you can see here from 3-member to 5-member ring, it's a ring expansion, and the reaction is important. As we have seen, once the question came where they have given the reaction of aziridine with malonic ester, and you have to design the product with the mechanism. So this is the 3-carboethoxy pyrrolidone is the final product here. So say many questions, many reactions are there under aziridine. Here we are focusing only those which you can write in your answers, or you can select from these also based on the number of marks they are asking for the question. Now azetidine, again, what is azetidine? It is a nitrogen containing 4-membered ring. So here also you can observe ring opening reactions, not very fast like in aziridine, but it will be there. So again, in the presence of acid, you can show the reaction, protonation will take place, and since it is symmetrical, either side the ring will open. In the presence of nucleophile, you will get the open chain product here. Formation of azetidine derivative. So formation of derivatives are very one of the frequent reaction of azetidine. Here we can see one example in the presence of formaldehyde, and you have a nucleophile nitrogen, you have a electrophilic center of carbonyl carbon. The reaction will take place and it is going to form NCH2OH. Various reactions are there, we are restricting here. So one question they have asked once: write a comparative account of the ring opening reactions of aziridine and azetidine. So especially they are asking for ring opening reactions, we have to compare. So first is azetidine is considerably a strong base. You can notice here pKa 11. Then the aziridine, whose pKa is 8, which is with respect to the ring strain. Since aziridine is having a less aziridine is having a more ring strain, therefore it is a weak base. Okay, so basically the basicity is governed by the strain here, ring strain. Aziridine being the most strained, the basicity is less here. So you can see the azetidine ring being 4-membered has less strain and than the 3-membered, and therefore the ring cleavage will be more slowly, it will occur in the azetidine ring as compared to the aziridine ring. So you can include some more points here regarding this, like thermal stability of azetidine compared to aziridine. The next question which we found is, what are azetidines? Give their general structure and synthesis. So first is azetidine is a saturated 4-membered nitrogen containing compound, and you can also tell it or designate it as a trimethyl amine. The structure of azetidine is this one, where you have triethyl amine. So structure and its synthesis, one can also design it. You can see here by taking gamma chloro propylamine, and in the presence of base intramolecular loss of HCl will give you the azetidine ring. Final product. Another reaction is, you can notice here, you can do the 2 plus 2 cycloaddition reaction by taking the nitrile functionalized group and by taking C double bond C alkene group. So addition of these two in the presence of photochemical condition, 2 plus 2 cycloaddition will occur, and you will get here the nitrogen in a 4-membered ring, which is a azetidine derivative. So like this, you can solve many more reactions under aziridine and azetidine. We are restricting with here because they ask either one synthesis or two synthesis maximum for the respective molecule, or similarly one or two reactions for each category. So we have mentioned that, and the topic is very important for M.Sc students and the competitive exam, and you have very less data on the heterocyclic small membered and higher membered ring size, like 3, 4, 7, 8 ring size compounds. So I am here trying to prepare the videos on such molecules so that you can get the benefit of it. And if you have any other doubt or any particular compound you want me to discuss here, you can write it in the comment section. I'll try to prepare it. Thank you.